This is CIT 1122, Module 5, Submodule 3, Evolution of STP, Spanning Tree Protocol. Let's take a look at the first slide here. Hey, there's a whole bunch of different kinds of Spanning Tree Protocol. Why is that? Because there has been improvements in Spanning Tree Protocol as time has gone along, and some of those improvements are not IEEE standards, are proprietary, but Spanning Tree itself, taking 50 seconds to load, it's a little bit of time. So they got some ideas and said, maybe we can distribute the load on Spanning Tree, and they came up with per VLAN Spanning Tree, and they said maybe we can make it a little faster, and we came up with the Rapid Spanning Tree that became available, which is a faster convergence of Spanning Tree that takes less than 50 seconds. And Cisco came up with enhancements for its Rapid Spanning Tree, and they called it Rapid PBST Plus. So on this particular slide, just please be aware of what's proprietary and what's vendor neutral. And then the next thing you want to be aware of are two functions for Rapid Spanning Tree, and one of them is that there are backup ports and alternate ports that have been added into the mix of port statuses, so be aware of those. And the other thing I want you to be aware of is something called PortFast and BPDU guard. Okay, so what PortFast states is this: is that if we've got a switch, and that switch is connected to a host, that host is not going to create a loop because the host is an end device. So at no point are you in any danger of having that host create a loop and taking down the entire network. So what you can do with interfaces that are connected to hosts is you can set up a function called PortFast. And what PortFast will do is bypass the 50 seconds that it takes for kicking the interface up by running Spanning Tree's standard procedure of blocking, listening, learning, and then forwarding. So you can go straight to forwarding when you use PortFast on an interface. Now, you're going to use PortFast. If you're going to use PortFast on an interface for hosts, that's fine. The other command that you're going to use is BPDU guard, which is going to keep the interface from accidentally being plugged into another switch, and then that switch not running Spanning Tree, and then creating a loop between the system, right? So you've got an interface, and the interface on the switch, here's our switch here, is connected to a PC. That's great. We are going to set up PortFast. PortFast basically should be called Bypass Spanning Tree Protocol, Listening, Learning, Blocking States. Just go directly to forwarding, okay? Now, if someone was to say unplug that PC and then take that cable and then plug it into another switch, and this switch is not running, or maybe it is running. If this switch, now that we've gone to PortFast, we're not going to check to see if it's another switch. So what we're going to do on this interface is this: if this switch could have created a loop, what it'll do is it'll send BPDUs will be sent back in this direction to this switch. So what BPDU guard is on this interface is you set up BPDU guard. It says this: if someone takes a port that's set up in PortFast and accidentally plugs another switch into it, it's not going to create a looping system. It's going to have BPDU guard on there, because if BPDUs are getting sent into that interface, then that will alert the switch to identify that that is another switch that it's connected to and not a host, and it'll shut the interface down. And that's what BPDU guard does. So these two things work in conjunction with each other. PortFast kicks the port up fast. BPDU guard, in case someone unplugs the host and plugs in a switch and it creates a loop, BPDU guard will shut the interface down because it would be receiving bridge protocol data units on that interface. That's what's going on with PortFast and BPDU guard. And that's it.